Hi, welcome to everyone's favourite segment, Mailbag. Let's get right into it. Thank you very much, Kyle Berezin, I think. And this one is a crowdfunding in progress. Please open ASAP. Hope we haven't missed it. Let's go. All right, what have we got here? Let's have a look. Reused. Is that a DigiKey one? Not sure. It is a motor with a 3D printed bottom on it. I think I got an email on this one. I do believe it is the OpenMYR Wi-Fi motor. Yes, you talk to it with Wi-Fi. You apply power and apparently you can control it Wi-Fi. Let's take a look. So here we have it. Here's our OpenMYR Wi-Fi motor with the 3D printed bottom enclosure on it for the Wi-Fi electronics. Yes, they are doing an injection molded version of this, so they say. So that's part of the Kickstarter. They're currently only up to about $6,000 or something of their $80,000 they want. So that's a lot. Anyway, I'll link in the Kickstarter down below, and yes, it uses the ESP8266 as the Wi-Fi radio. Now, I've hooked this up to 12 volts, and it's drawing about 200 milliamps or thereabouts, so about 2.5 watts, but I can feel that vibrating. I'll see if I can actually get the sound here. Anyway, it's got a built-in web page where you can actually control the thing from, and there's UDP packets, JSON, whatever that is, and not into that sort of stuff. And there's the quick start guide. You provide 12 volts. You open it up with your, in this case, I'm going to use my phone. We go to this address, and we should be able to control the thing. Let's give it a bell. Now, connected, no problems whatsoever. My phone found it and hooked up, but there was no security. And that's the thing with these Internet of Things gadgets. There is no security. We've had that recent security thing where, hack where this could become a zombie motor, and it could be hacked and, run malicious code or whatever. So, yeah, I don't know if they have security. You might be able to enable it in the setup, but by default, didn't have any. And that was too easy. We're in like Flynn, but I can't read any of that. GitHub, blah, 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 blah. GitHub page, configure, okay. Oh, control. Let's just go into control. I want to make it do something. Geez, that's too small by default. Let me flip that around, can I? Yeah, it's a bit annoying. Anyway. Ooh, what is Imperial March? Is that going to do the... There's all the codes for it. How do we execute? Okay, so we've added all these to the queue. So it's presumably going to be do the Star Wars Imperial March. So let's just send queue. It's turning. It works. And I might have to get the mic really close to actually get the sound of that. And if you go to the configure here, the only thing you configure is to join a network. That's it. And it will, yes, you can get this motor to actually connect to a network, but yeah, that's it. So I'm not exactly blown away by that. That's incredibly simplistic control. Like, it doesn't even have, like a turn left, turn right button or anything like that. It's just got a queue-based system, which is okay, in its own right and powerful and everything like that. But yeah, it's a Wi-Fi connected motor. Okay, and that's exactly what you'd expect inside a Wi-Fi connected motor. We've got our Wi-Fi module and our motor controller on the bottom there. And that's an A5984 for those playing along at home. Not much else on there at all, but you wouldn't expect it. Next up, one from Germany. Hi to all my German viewers. This one's from Sebastian from Berlin. Haven't been to Berlin. Let's crack it open. I'll give you a little bit of a spoiler. Contains old stuff. Beauty, we like old stuff here on the EEVblog. Wow. Jeez. What's that? I think that's it. Oh, swagger stuff. Wow, I can't even look at it all here. Are they yes, some of them are tubes. Ooh, I like that. Little center 0 meter. Tons of stuff. Let's check it out. Well, it looks like we have the old component bonanza. Look at this. I can't possibly do justice to every one of these parts. So, yeah, maybe I'll go through them just quick and highlight a few oddball ones, maybe. Oh, check out all these old chips and that huge Texas Instruments ceramic package. Look at this, the TMS 1099 SE3. Apparently this, well, date code, 22nd week 1979, but apparently it dates before that. This is a support chip which was used on the evaluation boards apparently for the TMS 1000 series processors. So very interesting, but look at that beast. Ah, they don't make ceramic packages like that anymore. NEC Jobby Sprague. A couple of Spragies, and ooh, what's that? Photosensitive package. Tesla. No, I don't think that's Tesla, the car company. But Godson, what on earth is that? No clue what that is. Look at that package. What the? Are they like high tension wires in there? It's in a standard dip package. Oh, here we go. ID code. What is it? No, that may not tell us much. So is that like some sort of display? And designed to put multiple ones side by side, plug them into a board? Yeah, some sort of vacuum fluorescent display thing? And here we've got some sort of camera tube. I Google the number and I get a Radio Museum that entry that just identifies it as a camera tube, some sort of, I don't know, photo multiplier tube or something, I'm not sure. F2.5 M31B for those playing along at home. Love the nipple. Ooh. Okay, what is that? I don't know. I don't know. Anyone? Anyone with a clue what that puppy's doing? And this thing is interesting. It's got a frequency on it. Look at this, 7.8, just over 7.8 meg, and it's got, is it some sort of resonator? Some sort of, you know, it's not, I don't think it's a quartz, is it? Like, that is weird. Has anyone seen anything like that before? Check that out. What is that? Is it some sort of quartz crystal kind of thing? I don't know. And I love this old school center 0 meter. Look at that. And what is that? 1 degree equals 4 times 10 to the minus 6. So 4 microamps. 1 degree. Does that mean like 1 marker division or what? Or is that lines up with the 10? Or is it actual degrees of movement from the center? I'm not sure, but yeah. I just love old school meters. Very nice. Now here's something more familiar. This is a quartz crystal. Most definitely, because you open up a modern, you know, HC49U, and you're going to find very, very similar to this. Physically inside the circular disc like that, with the pads either side on the quartz substrate like that. So that is definitely a, what frequency? 2048. What? Anyway, that's definitely a quartz crystal in a tube. This unusual looking thing is some sort of filter, by the sounds of it, a band filter. There you go. So yeah, some sort of bandpass filter, mechanical bandpass filter, presumably. And we've got yet another band filter. Look at this. This one's even more interesting in that physically on the other side, look, we've got like a almost like a standard transistor type metal can package, one at either end, mounted either end of that can. So that is fascinating, but unfortunately to get that open, I'd really have to you know, get the Dremel out and it'd be really messy. It's not for Mailbag. And once again, some sort of photo tube type thing. If anyone has any idea, like, you know, I don't know, I'll just throw out the generic term, some sort of photo multiplier tube or something like that, perhaps. And then we've got another little bonanza of filters and old school stuff here. Once again, we've got another one of those packages. More old school. There you go. We've got the old lens on the top of the metal can trick. And there's another jobby down there, which is going to be photosensitive. And I don't know what that is. Anyone? Bueller? Bueller? What on earth is that? Look, this thing moves in there like that. I can only presume it's some sort of mechanical vibrator. It might be some sort of, you know, mechanical filter or something like that. And it seems we have some swag. Who is Afra-Berlin Deutsch? Hackerspace, is it? I don't know. What on earth is that? I've got no VCFB.de. Aha, that is the Vintage Computing Festival of Berlin. Oh, I would love to go to that. Awesome. And of course it's the Spectrum. And what else have we got? We've got some stickers. Caution, device contains atoms and is a tiny bit radioactive. And a whole bunch of made in China stickers. Oh, no way. Geez, they're plugging everything. Rebit your universe at cbase.org. Wow. What is that? Almost like it's some sort of bridge rectifier. Yeah, cell? It's not a selenium rectifier, is it? Ooh, Ford branded. Thank you very much from Philco, Ford Corporation, Microwave Department, Microelectronics Division, Eastern Operation. And we have, it looks like, some diodes, microwave diodes. Wow, in their original packet. Beauty. Okay, what is that? I don't understand what this thing is. Is there something in there that we need to... What? Oh, yes. Oh, look, it's a carrier. It's a carrier for some RF transistors or RF amps. Beauty. Check it out. You can see the ceramic package there, which is the purple bit, and the 4 leads coming out. These are classic RF transistor or amplifiers in a package, and you just solder, basically surface mount these directly down to the board. Very nice. Usually you'll have a little cutout, hole cutout for the main package itself, and then the 4 leads just go off to controlled impedance traces, of course. Thank you very much. And that looks for all the world like some sort of CDS photo cell, perhaps. Like a big-ass one. I don't think I've ever seen one that big. Wow. Okay, what is that? What on earth is that? My first guess on that would be some sort of, like, programmable matrix plug or something, perhaps. If you ripped all that stuff out, maybe you'd find some interconnects in there, but as far as some sort of active stuff being in there, I doubt it. 200 meg resistor, thank you very much. Doesn't that look beautiful? Ah, it's a work of art. Yeah, we've got more random stuff here. Look, very old. Is that Phil? Is that, it wouldn't be Phil brick, would it? Or is it an early Philips or something? I don't know. Carrier for a, oh, there's the number on the back for those playing along at home. 1978, in their original ceramic packages. So some sort of chip. And, oh, there's some sort of photo cell again. Another one. Another classic. Who makes it? Hyman. Yeah, no, well, used it lots. Not. So thank you very much for that absolute bonanza of old parts. Absolutely fascinating. Wow, what a score. Next up, one from Australia. Beauty. This one's from PD Miller from Salisbury in Queensland. Hi to all my bloody Queensland viewers. Bloody Queenslanders, that's what we call them. Yeah. And wrapped in electrical tape. And it's just completely mangled too. It's like, unbelievable. Anyway, street cred for the electrical tape. Let's get into it. All right, here we go. It's in here. This. Doesn't look the shape. It looks very industrial. It's a Crompton digital analyzer. Like one of those industrial panel mount digital analyzer. Is from a very large main switchboard that just faded away and stopped working. So it's dead as 1998 vintage, and let's crack it open for a 2-minute teardown. So this is a power analyzer, apparently measures volts, amps, power factor, all that sort of jazz, and reports back. Let's tear it down. And made in the old Dart too, thank you very much. Screw that. And we're in like Flynn, multi-board cube construction there. Ribbon cable going off to our touch buttony things on the front, so we'll rip that out. And fairly typical construction. Oh, that's been... somebody's hand soldered that puppy. Something's gone wrong there. What, they changed the transformer? Or is that how sloppy it was? They just didn't clean it when they manufactured it. Anyway, looks like we've got some current sense transformers in there, do we? 3 of them? Because it's 3-phase, is it? Oh, TO220 with a heatsink flapping around in the breeze. It's pretty how you doing. Old school Siemens ADC 517 in a PLCC socket. Thank you very much. So they've just mixed in the old school through-hole stuff. There's the ROM for it down there. And is that an E-square prom or something maybe? I don't know. Can't make it out. Raytheon? No, what's that? But anyway, they mixed that with the surface mount controller down the bottom for the LCD, and that may not be made by them. Dead giveaway, you know, PCBs are different colour, different manufacturer, everything else. So that may be, I don't know, some sort of off-the-shelf module they built it around, or designed it to, or had it designed for them, or maybe another group actually designed the LCD. But yeah, it'd be common to farm that sort of thing out, because you're not going for a low price point for this thing. So just use an off-the-shelf display solution from somebody else. And that looks like it'd be Data Vision. Next up, one from Neutral, Switzerland. Thank you very much, Pascal Stadler. And it contains defect electronic, or however you pronounce it in, or spell it, say it in Swiss. I don't know. But we've got some more busted stuff. People like to... One of the interesting things about Mailbag is the great differences in packaging style. Oh, geez, I like those. They're those rugged lift buttons, you know, like industrial type buttons to be used by the public. That, oh, I got ourselves a calculator. That's not a 4-banger, and these are like, you know, like 10 million operations or something insane. Oh, for all you Casio fanboys, oh, it is a bloody 4-banger. It didn't look like a 4-banger, but it is. On. Still works. Of course it does. But, well, it's a 4-banger. Anyway, 2-minute teardown. What else have we got? What on earth is that? TI? Oh, okay. It's a TI. For all you TI fanboys, I know you're out there. It's a TI 74. I just didn't recognise the... someone's put their own custom plate on there. Wow, the TI 74 basic calc. Wow. Brilliant. Wonder if it still works. Does it power up? Nope. Oh, I've got our ROM cartridge and everything. Oh, terrific. So that is brilliant teardown material. I've never actually seen one before. That's a protective case. I guess you don't have to have that. But, oh yeah, 4 AAAs not in there. But we'll try and power this puppy up. Serial number, thank you very much, 5112. Wow, that's early, 1985 vintage. Wow, that's a Bobby Dazzler. Casio HL121, thank you very much. Oh, look at that. Ooh. But still works, as do all these Casios back in the day. But if it ain't scientific, I don't want to know about it. As a kid, I was always fascinated by how Casio always put like the power consumption in watts with decimal points on there afterwards, and I was like, oh, wow, that's so incredibly low. Like, you know, like I didn't really understand like you know, microwatts back then when I was like 8 or something like that, but I thought, you know, that was just ridiculously low because, you know, I'm familiar with like a 100-watt light bulb and stuff like that. But yeah, 450 microwatts, thank you very much. Single-sided, like phenolic type base. None of this fancy-pantsy expensive double-sided, you know, high-quality fiberglass rubbish. No siree, Bob. But there we go. Now, the interesting thing about this is that it is actually a double-sided board, so to speak, but it's not on both sides, hence why you can't really call it double-sided. It's a single-sided board, but it's dual layer. You'll notice that the jumpers on here, it was easier for them to do a separate layer on there than to drill the holes and have plated through holes and everything else. They just put them on there and as a separate process made contacts and then bridged them over, solder masked them and then bridged them over again with another bit of copper. I'm not sure of the exact you know, manufacturing process of how they do that, but yeah, they just jump them over like that, and it must have been cheaper than plated through holes at the time. And Pascal actually got these from his teacher in this classic TI-74. Oh, hands up if you had one of these babies, the basic calc. Yeah, it's got a classic like school nameplate on there. Oh, hallelujah. Look at that. And with a handy reference chart. Thank you very much. Does it still work after all these years? Ah, oh, you bet your ass it still works. Look at that. A single line display. How many characters is that? Like, 24, 30? You can just switch it between basic mode and calculator mode. And of course, in basic mode, you can just put commands directly in and run a program. Easy. So I've just entered a short program here. List. Can we go down? Yep. Print C, next C, and let's run it, shall we? There we go. Woohoo! Look at it go! The speed! Hold on to your hat. So this puppy came out in 1985 and had 32K of ROM, 8K of RAM, and that was in this pack. Doesn't tell you, well, it's presumably an expansion pack, but it doesn't actually tell you what size this puppy has. Anyway, this was a bit of a beast back in the day. And that's a seriously low serial number too. Wow, 5,000 odd. And wow, look at that, all through hole. Thank you very much. TMS 70C46 processor, 1985. There you go. And well, there's our RAM. Yep, we've got some RAM. And that's a that'd be custom built-in ROM, of course. You've got a 7660 voltage inverter there. That's for our contrast pot. That's all for the LCD, but wow, all through hole, old school, love it. So that's, I think, really a sharp contrast to the, no pun intended, the Sharps and the Casios, the little pocket computers of the day back then, because they were all running surface mount. This one is like, yeah, just completely old school. They haven't put any effort into getting this thing down at all. That's why the thing's so damn thick, but I guess they didn't care. They just wanted to get something out. So thank you very much, Pascal. That's a beautiful bit of old school classic pocket computer, mid-80s vintage. Wow, love it. We've got ourselves a second suck of the Sav here, Nivdi. I think I'm pronouncing it correctly, maybe. It was on a previous mailbag not that long ago. Nivdi's from the old Dart, as in K-N-I-V capital D. Anyway, from the old Dart from Hatton Garden. Wow, that Hatton Garden robbery, that was absolutely fantastic. I would have loved to have been, like, you know, I don't want to go steal people's stuff, but, you know, just from... actually, you know, I love heists and stuff like that, and I especially love heist movies. They've just turned it into a movie, and it's out, apparently. It's, yeah, it's just released a trailer or something like that. And, yeah, definitely worth a watch. A bunch of old codgers abseil down a lift well and everything. That's just cool. Anyway, awesome. And yeah, we've got more of these proto board thingos we saw last time. So we've looked at these router boards closely previously, and well, we don't need to go over them again. They're like an FPGA interconnecting type matrix proto board, quite neat. And this is the upgraded version with feedback from the Kickstarter campaign backers and the people who commented previously. So there you go. Link it in down below. Swedish post time. Hi to all my Swedish viewers. I like the stamps. Very nice. This one's from Daniel Jensen, care of Veriday. Is that a website? YouTube channel? Not sure. Let's check it out. We've got static shielding. Sorry, static shielding bag for our protection. So there's obviously electronics in here. Esteemed Mr. Jones, thank you very much. Daniel, okay, switchandlever.com, hence their little logo, which is a switch and lever. Cool. Anyway, I'll show you close up. Pull here. Pull here. It's got to come out the right way. Oh, it's old school. I thought it was something, I just assumed it was something new. Got ourselves another calculator by the looks of it. How does that, oh, there we go. Oh, another 4-banger. A Hugen, it works. It works. A Hugen professional calculator. Oh, wow, it does square root. 1 on it. Oh, man. Yes. Where's that from? Wow. Is that Swedish? 0.2 watts. It draws. Oh, classic. 2-minute teardown. And this puppy comes from the Kingdom of Sweden. Fantastic. We haven't had I don't think we've had a Swedish calculator on here before. And let's switch it on. Ooh, look at that greeny goodness. Fantastic. Oh, look, hang on. We could do pi. Look at this. Oh, pi. Wow. And look, we can get square root of pi. Come on. No. Oh, sorry. Duh. Operator error. And if we get it back, we can square it. Wow, what can't this thing do? Oh, look at this. Yes, we have nipply goodness. There it is. And whoop, we're in like Flynn. Beauty. So there's not much in there, but an NEC chipset. Oh, the resistor network, pull-up resistor network, thank you very much. And that'd be for the keyboard, and a little transformer there for getting our high voltage required for our vacuum fluorescent display. So thank you very much, Daniel from switchandlever.com. There's a serial number for those playing along at home at 3 volts, only 0.2 watts. Ah, bugger that TI job. Geez, this is a professional model. Got one from Deutsche Post, yes, it does have a name, Marcel Thuma. Thank you very much, Marcel. Let's, easy open pull tab, only to find yet another easy open, no. Wow, alright, what do we got? Got some long boards. Oh, that looks like a Microsoft Kinect. Is it? I've never seen inside a Microsoft Kinect, but that kind of looks like, doesn't it have 2 eyes? Or no, am I mistaken? I should read the bloody note, shouldn't I? No, open door from GEZE and 1 defective ebook reader. Oh, we have a defective ebook reader. Wow, what? Bookeen. Bookeen. Does anyone remember a Bookeen? I bet you they're out of business. Designed in France. French. Le Book. Le e-reader. And a couple of blank boards. Let's check it out. Okay, so this is not a Microsoft Kinect. I was totally mistaken. It's got some bodge wires on it. But there's 2 sets of lenses here. So it's some sort of stereoscopic vision-y type thing. Oh, okay, no, there's an emitter. Okay, so it's an IR emitter and presumably and receiver. So this thing looked all fancy-pantsy with its big lenses on there, and you thought it was doing some big, you know, stereoscopic, you know, viewing thing, but no, it's just a door opener from a German company called GEZE. And there's the, we don't even have to take it apart, because there is the board inside this thing, and that's it. It's just got an infrared transmitter and receiver, and Bob's your uncle. It's just an automatic door opener. Aww. So that's the emitter, and check out the receiver over here. We can adjust the position of the receiver. Thank you very much for presumably a certain distance. Well, there's a bit of a surprise directly behind the lenses there. Sensor directly embedded under the PCB. That's the most interesting thing about this. I didn't expect that. I thought, you know, there'd be some sort of, you know, metal can package or something behind there. And this poor old Cybook Odyssey is still updating. Yeah, that dude's going to be sitting on that park bench for a while, I think. And because that's the thing about e-ink displays. They stay permanently at their last display. They don't require any power. Did anyone have one of these things? The Bookine? Designed in France, made in China. That came apart disturbingly easy. Yeah, not sure what's going on there. Anyway, I think the battery's gone. I can't see the battery. I think it was up here, and trust me, there's nothing in the case. Yeah, look, yep, you can see where it's been ripped out of the top there by the looks of it, but yeah, you know, a fair bit of engineering's gone into this thing. It's designed in France, obviously. It's actually quite nice. 2012! Wow! 2012, that's pretty recent. Jeez, there you go. Anyway, is that ourselves a Wi-Fi chipset down there? And we got ourselves a micro SD card, have we? And USB, and that's about all she wrote. I like the angled connector like that is coming up at the side. Thank you very much. None of this straight, you know, 90-degree rubbish. And they got that to an almost single-sided load, except for the poor old tactile switches on the bottom here. Oh, what a bummer. And that's a TI OMAP for those playing along at home. Jeez, look at all the bypassing. Tons of it. None of this bypassing on the bottom rubbish for your BGA. No sirree, Bob, just stick it out to the side. Don't worry about those massive inductive connections going over there. Just whack them all on the outside. She'll be right. That's a bit, you know, that's a bit how you doing. There's got to be a point where that becomes, like, pointless. You've got to have them directly on the back. Well, it would be under there if yeah, but there's nothing under there, trust me. And they've just whacked them in a line, because that looks nice, with, you know, signal integrity. Yeah, that's not the best bypass layout I've seen, let me tell you. They should have been on the bottom. And considering that they double-sided load with those switches anyway. So, yeah, not sure what's going on there. That's a bit how you're doing. So that's almost as if, like, the schematic designer knew what they were, i.e. the designer knew what they were doing. You know, they specified, if you have a close look at these caps here, you'll see that they're different types, and they'll be different values, of course. You know, they might be 1 mic, 100N, 10N, 1N, something like that. You know, if you go look at the implementation note, the data sheet for the OMAP processor, they probably tell you a typical bypass configuration might be 3 different value caps. I've done a video on this explaining why that's the case, why you'd have different value caps in parallel, so I won't go over that again, but it's like they put that on the schematic, and then the PCB layout person just went, oh, I just whack them all in a nice neat row on the outside. That'll pass the design review meeting. It looks nice and neat. When really you should be putting them as close as possible underneath the chip directly onto the power pins, even sacrificing the required number of caps just to fit them on the bottom. Because once you move them out here, it loses their effectiveness somewhat. It's, you know, the inductance of the traces going under to the power pins. This would all be power playing under here. This would be a, you know, well, would it be a 4 or a 6 layer board? You know, something like that. But yeah, it's just, no. Don't get many envelopes, so let's check it out from Neville Nobody. So, it's something, it's not just a postcard. I feel something in, well, it is a postcard from Palm Cove in Cairns. So it's a local jobby, and been to yes, I've been to Palm Cove. Sure I have. Oh, and we have a patch, the South African National Antarctic Expedition patch. There's lovely Palm Cove in Cairns, and this is from Hardy Piner. Anyway, what's the answer to this question? I think it has an important meaning for life. I so want to go to the Antarctic. I'm totally jealous. That is definitely on my bucket list. So there you go. I hope you enjoyed today's mailbag. If you did, please give it a big thumbs up. I'm sorry if there were any audio or video issues in here. My stupid Canon HFG30 camera has just the backup battery, wherever that is in it, has completely died in the arse. And all my camera settings, which I normally have it all set up, you know, the white balance, the audio and everything else, even, you know, the recording format and all sorts of, you know, focus settings and all sorts of stuff. No, that was just entirely all just reset from scratch. So, and yeah, I had to use an auto mic and I left it on. Bloody don't let me complain about video blogging. Anyway, maybe give it a thumbs down because I'm not very professional. Catch you next time.
And next up we have one from Luke Stone in Wangaratta, which is in Victoria, Australia, if you didn't know.
But how me put a chocolate?
You took the golden doors off, Sadie.
No, how me put them back on?
I don't know.
Then
yes.
how me put the golden
F-boss
doors
machine.
back on?
So you want to press the green button? Look!